Does he not live near a bus route?
I think
I have no idea where it is. Interesting. It was up there.
it was bought for the fire department.
Yeah,
Like down like Olympia?
Yeah.
it was on Citrus Street.
Okay.
It was for yesterday.
All right.
You got it wrong.
Alright, why didn't you go pick up your best friend?
I didn't know.
Jeez.
He never texted me.
That's supposed to be your best friend.
You just show up.
Oh, there he is. I see him walking this way. Boy.
All right. Is this a factor?
I guess he fixed his truck.
No.
He fixed his truck, I guess.
One, -2, 1, -2, -12, +24, 0. Is that a factor?
Yes, ma'am.
Yes. And then number 5 says, what reasoning did you use? Okay, so how do you know if it's a factor or not? If the remainder is 0, it's a factor. Okay, if the remainder is 0, it is a factor.
It is a 0.
Excuse me, so sorry.
All right, x plus 2 and x minus 3 are the only factors of the function g of x. How many times is each a factor? Well, let's see. -2, 1, 1, -8, -12, 1, -2, -1, 2, -6, +12, 0. We'll try that again. 1, -2, -3, +6, 0. 1. Nope. So that one's 2 times. 2 times for that one. And so this one's 2 times. This one has to be 1 time because there are only 3 factors, just so you know. But I'm going to go ahead and do the math. But it's only going to work 1 time. 3, 1, 1, -8, -12, 1, 3, 4, 12, 4, 12, 0. That's it. Those are all 3 factors. There's no point in going any further. Like, well, what if it goes again? Okay? It can only go, like, that's it. 1 time. 1 time. All right. I don't think it's locked. Just kidding. It's locked. JK, JK. All right. This is not you.
Okay. I guess I'll just take that.
Oh, I need to fix it. Remind me before you leave to fix it. You're actually here.
Okay.
Okay. If x equals 3 is a 0 of the function, h of x, what factor is a factor of h of x, and how many times is it a factor? Okay, well, first of all, x minus 3 is the factor. Is factor. How about we use a noun marker? Is the factor. Is factor. I sound like a caveman. All right.
That's Russian.
Oh, is it? Okay. I did fall asleep to this thing about Chernobyl last night. It was so boring though. And it was depressing. 4, 3, 2, 1. I think I heard people talking about this one yesterday. A lot of people started working on this one and didn't put those in order. Because you notice they're not in order. Yeah.
I didn't do that. I didn't do that.
Yeah.
And I'm always the one person that doesn't ever put it in order.
Yay. All right. So let me do this. And then this. And then the -2 comes down.
-6,
It's -6. That's going to be,
17.
whoa, isn't that 13?
Yes, yeah. Oh.
And that's 39. And -24. All right. And then -72. 9, 27, 0. Okay. Do it again. Thanks for these ginormous numbers. -6, 7, 21, -3, -9, 0. Let's do it again. Let me pause to get a drink of coffee. Coffee. Okay. Kind of out of space here. I should probably rewritten this. 2, 6, 1, 3, 0. All right. Let's try one more time. I'm gonna have to rewrite over here. 2, 6, no. Oh wait, that's a -2. My bad. It's a -6. It's still a no. It's a no from me. So x minus 3 is the factor 3 times. Can I put thrice? Oh, yeah. I put that. That makes me automatically smarter than all of you.
Middle
Yeah,
English.
you're already
I bet y'all don't know this middle English.
Yes. Boom. Thrice.
This is not a fancy word, just one of those.
Woo, some of y'all are smarter than me, for real. That's not even a joke. All right, let's look at number 8. Can I move this, or are you still writing out thrice? You, Katie, can't roll her tongue. Katie Beth, that she can't do that.
Okay.
She can't do it. She tries. She spits all over you, so she can't do it. Apparently it's a genetic thing. So,
I can do it, but I just don't want to.
all right, number 8. Who does that? Oh. That's funny. She can do this. She can do that, but she can't roll her R's. But she can. Yeah, maybe someday she can.
Doing forever learn how to whistle.
She can whistle like a champ. In fact, it's so funny because my nephew and my great nephew just yesterday, they were mad because she can whistle and they can't. And she was like, she's so annoying with her whistling, always showing off. And I was like, that's so funny that they're mad because she's showing off. You know, to be like 7 and 8 and have all that 7 and 8-year-old drama, like, oh, she's always showing off her whistling. It's so funny to me. Like, dude, there are much bigger problems in this world than the fact that a girl can whistle and you can't. So, but whatever. Oh my goodness, boys. But you're above all that now. Yeah, that's right. Grown and matured.
Goes over. We met at the park after school. No more whistle.
No more whistling for you.
You're not gonna be able to whistle when I am done with you.
All right, so let's see. On this one, it's a factor, and then I have to find the other 2 factors. So I just have to do some synthetic division to get my depressed polynomial. He's depressed because he can't whistle. And then I got to factor that. Okay, so let me go over here. And over on the side, I'm going to do some tic-tac-toe factoring. Because I know some of you use the bottoms up. I think the majority of you use tic-tac-toe.
Literally, Julia's all.
Yeah, and I think the people who are still struggling are using tic-tac-toe. So that's why I need to show you that one for real. All right, so I needed to multiply to be a -2x squared and add to be a positive 1x. So I'm going to use a positive 2x and a negative 1x. And if I multiply those, I get that number. And if I add them, I get that number. Okay, so now I'm going to go over here and I have to come up with something that multiplies to be 2x squared. So I'm going to put a 2x here and an x right here. And the reason I chose that is because in just a second, when I fill in that middle part, it has to multiply across as well. Okay, so that's why I put the 2x on top. If I put the 2x on bottom, I'm in a bad way because then I've got to multiply 2x times something to get me a -1x. And the only way to get that's a fraction. And I know how y'all feel about fractions. Yeah, you don't want to live that life. Okay. So keep it across where you don't have to. And then, well, what times 2x gets you 2x? 1. And what times x gets you a negative x? A negative 1. So I have a factor of x plus 1 and a factor of 2x minus 1. Right. So I've got f of x equals x minus 2. That's the one they gave me. X plus 1 and 2x minus 1. All right, now number 9, we need a graphing calculator, which I have. There. Look at that. Isn't that fantastic? That's one of my new toys I just got. It's pretty awesome. Okay, so if I want to graph, I'm going to go to y equals, and I'm going to put in 2x cubed, x cubed minus 3x. Let me just pick this up. 3x squared minus 3x plus 2. Is this the one that we just had? Is this the same problem as number 8? Oh, okay. Just have to graph it. Okay, so then you go to graph. There it is. It's beautiful. I love it. Okay. And then it said, explain why your work in exercise 8 is validated by this graph. Okay, so I'm looking at this, and I'm going to graph it on my paper. Pass this through right here. Right here. Three. Well, mine's not great. Okay. So there it is, right there. Yeah, it looks just like it, right?
Mm-hmm.
Yeah, it does. Yeah. All right, and then it says, explain why your work in exercise 8 is validated by this graph. Well, because I have a 0 at -1, at a positive 1/2, and at a positive 1, I have factors. The factors are x minus 2, x plus 1, and 2x minus 1, which means there are zeros at x equals 2, x equals -1, and x equals 1/2 as shown on the graph per my last email. All right. Good. Still writing? Need to wait? Okay. Got it? Okay. All right, number 10, for what value of k? So I need to put -3 here. And then I'm going to have -3, K, 20, -12. Bring the -3 down, and then that's 9. So that's going to be K plus 9. Then you have to do distributive property. -3K minus 27. When you add 20 to that, you're going to have -3K minus 7. Then you have to do distributive property again. So it becomes 9K
You wouldn't,
plus 21.
so when you're doing that, like, -3x minus 1/7, you don't put the 20 with the 3.
No, they're not like terms.
That's just missing.
Mm-hmm.
You have
Oh, wow.
9K plus 11.
9.
Yeah,
Mm-hmm. So 9K plus 9 has to equal 0. 9K equals a -9. K is -1.
Yeah, well, yeah, I goofed up a little bit. I goofed up a lot. What would you divide it by? Would you divide by anything?
Here?
Yeah.
Yeah, divided by 9, so I could get K by itself. -9 divided by 9 is -1.
Oh, okay. It's gonna be solid.
Yeah, it will be.
Because all the AP kids are gone, seniors are gone. Well, what I did is whenever you put that -3K, I put a 2 there. And then
Oh.
when you put that 9K, I put a 3 there. Because I thought it was just like 1, 2.
Right. No, you have to do distributive property. Oh, I forgot my money. Oh, man.
Do you know if you're getting back after AP testing?
I do not. That's a Mr. Parrish question.
If they're coming back, they're not.
They're not coming back?
Okay.
Okay.
So set up the-
Who
I
told
need
them?
to find out Mother's Day gift. No, I don't know.
That's what I said.
What?
But then Ryder wants to yell at us because he's like, the AP testing is so much harder than the ACT.
The calculus AP test is way harder than the ACT. That's for sure. But-
It's A-push.
Yeah. A push is a lot of just writing. Yeah.
See why they push.
Yeah.
I know.
I don't know. I think it's harder because you have to write all those essays.
Yeah.
Instead of just multiple choice.
Well, I will say this: when I took that test last Monday, the multiple choice to me was way harder than the essay. But I ran out of time on the essay and did not run out of time on the multiple choice because on the multiple choice I was like, I don't know this. Click. I don't know this. Click. Or you look at it, you're like, I know this. Click. So I got through those a lot quicker. But on the essay, I had to write 7 essays in an hour and 20 minutes.
Yeah, no.
I was like, I don't have time for this. So I ran out of time on that. I mean, I got something written on every one of them, but some of the essays were like 2 paragraphs in a sentence, you know, not really an essay.
Yeah.
I forgot my money. I'll have to run home at lunch and get it.
Money for what?
Money for they're selling barbecue for a fundraiser, and like
Who is?
TSA, they're selling like they're gonna do lunch on Monday, and
Ruth. They can't even give us.
right. But the biggest thing is like what's gonna happen is if I don't remember to pay, I'm gonna be real cranky Monday because everybody else could be eating barbecue, and I'm just gonna be looking at them like, you know. So I gotta go home and get some money and come back because I want to eat some BBQ. Okay, let's do this last one. And that's going to be 3, 2, K, -2, 1.
I may have not. Well, yes, I did. No, I didn't.
So bring my 3 down.
It just depends on
It's 5. Now right here is where you start having an expression. That's going to be k plus 5. But luckily, you just have to multiply it by 1. So you don't really have distributive property to mess up. These are your like terms. So that's going to be k plus 3.
I was wondering. That's what it was.
K plus 3, k plus 4. And k plus 4 has to equal 0. So that means k is negative 4.
This is the easiest case problem.
That was a pretty easy one. Yeah.
I keep thinking that you have to distribute everything for 6. Yeah. I don't think we distribute. I think it's like 1, 2, 3. Oh. Well, no, I think I did pretty good. At least we're trying.
Yes,
At
I'm
least
so
we're
glad
here.
you're trying. Yeah, let's talk real quick about the schedule coming up. So Monday is graduation. We'll be here Monday, but nobody will be in here Tuesday. Annabeth, yeah, she'll be in here Tuesday. And then Wednesday is the AP Lang test, and so that's going to take out not everybody, but a few.
Jackson
And Jack
Yeah.
and
and
Randy.
Randy. Oh yeah, I forget he's in there.
Okay. Yeah. And then Thursday is test day. Oh no, it's not. Just kidding. It's
It's just a regular.
review. Friday's when your semester test starts. And some of you in here have to take the semester test. We go by days and grades. So you will have to take the semester test. So we will review Thursday. We're gonna go ahead and do this last section. There won't be a quiz or anything over the last section. We're just gonna get it done. Okay? Because you need to know it. You're gonna have to see it again next year in Algebra 3. So I'd like for you to see it one time now, and then next time in Algebra 3 it'll be the second time you see it, and then when you take college algebra, it'll be the third time you've seen it. So you'll be like, oh, I know this. Yes, Miss Harper went over this 2 times now. So
On next Friday, are you giving us our test?
I will give you your semester test next Friday.
Okay.
We'll go over Thursday. We'll kind of start going over it when a lot of people are taking that AP test. We'll start talking about what's going to be on it, and I'll start posting it, and then we'll do examples and stuff on Thursday, and then we'll take the test Friday.
Can you tell us when you're gonna take it or not? Or can you not?
I probably can Monday, maybe. I don't think I can today. I don't think I have time to go through all that because I have to average your 2 9 weeks together and check your absences.
For both of them.
Mm-hmm.
Well, I
Yeah,
got
I wanted to
100
say
in here,
German. I
baby,
forget
so
that.
I'm okay with
Yeah, it's your 3rd and 4th 9 weeks average and all your absences since Christmas. Since we came back after Christmas break.
I just only missed 2 weeks.
Pretty hard to take it.
Yeah, Randy.
I mean, I'm just going off on one.
Randy, I feel like you're going to be taking that test.
But I'm just feeling like
I think I have to take it.
Well, they haven't taken 2 of my absences out of my thing because my doctor's note. And then,
Well, it still counts as an absence.
Yeah.
It's just
oh,
excused or unexcused. You get to make up your work or you don't, but it's still an absence.
that's so stupid.
Yeah, if you are not here or
Well, I'm
not.
glad I didn't have stroke, or I would have gave it to everybody.
Yeah, yeah.
I wish I would have gave it to them people. Sorry, your mind's. That's so stupid. Well, one of those days I get excused because I had to go take an interview.
If it was a school thing, then that doesn't count. But if it's anything else, that counts. All right, so let's look at page 502. Graphical properties of polynomial functions. Okay, so really we're talking, when we're going to talk more about that multiplicity today, we're talking about some traits of different properties or different polynomials. All right, so this is a cubic. This is f of x and it's a cubic. G of x right here, that's a quartic. So this is an x to the 3rd kind of function, and this is an x to the 4th kind of function. And then this is a quintic. So this would look like x to the 5th. So we're going to talk about in behavior. Left in behavior, if it's on the left side, then x is going off to negative infinity. If it's, because this is negative infinity and it's on the left. Okay. Right in behavior goes this way. So x is going off to positive infinity. Okay, so that's, but we haven't talked about the end behavior yet. We're just setting up where it's happening. Okay, so let's look at the left side. When x is negative, when x is going off this way, what's the graph doing? It's going down, and down is also negative infinity. F of x is going to negative infinity. Anything left or down is negative infinity. Anything right or up is positive infinity. What's the left end behavior over here? As x is going off to negative infinity, what's happening on this quartic function? It's going to positive infinity because it's going up. So that's g of x is going to positive infinity. What about this quintic? As x is going off to negative infinity, what's happening on this quintic? Where's h of x going? What's happening on the left side of that graph?
Going down.
Yep, so that's down to negative infinity. So that's the left end behavior of each one of these. When it asks for left end behavior, it's asking you what's happening on the left side of this graph. Is it going up or is it going down? If it's going up, up is positive. I mean, you can look up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are positive numbers. If it's going down, those are negative numbers. All right, so let's look at the right side of the graph, the right end behavior. What's happening on the right side of f of x? It's going up, so that's positive infinity. So as x goes up to positive infinity, the graph f of x is going up to positive infinity. What's happening on g of x on the right side? Going to positive infinity.
Need to fix that.
What do you need to fix? Are you okay? Okay. What's happening on the right side of h of x?
It's going infinity.
It's going to infinity. All right. So you've got end behavior. End behavior. Let's look at the zeros. What are the zeros on f of x?
A to 2, A to 1, 1.
Yep. Okay, I'll let you write those down and then we'll talk about the next question. If those are the zeros, what are the guaranteed factors? Like x equals -2 would turn into what as a factor?
X plus 2.
Yep. And x equals -1 would be,
X plus 1.
yes. And then x minus 1. Yes. Oh, so smart. Love it. All right, what are your zeros here?
A to 5, A to 2, and 2.
And x equals 0.
Oh, right there.
Yeah.
Yeah, I didn't know if you were
Yes. Yes, you do. So what are your guaranteed factors?
X plus 5. X plus 2.
Mm-hmm.
X minus 0.
You can just put x, because what's x minus 0? X.
Okay.
And then
X minus 2.
x minus 2. All right, now let's look at this one. Negative 4. Negative 2. So this one has a x equals negative 4, x equals negative 2, x equals 2, and x equals 5. Yep.
Plus 2,
Mm-hmm.
minus 2.
Yep. Yes. Very good.
Yeah, I know.
All right. Define a multiplicity of a 0. We talked about this already. It's the number of times that an x is a 0 of a function. All right, so the graph of f of x, all the zeros have a multiplicity of 1. G of x, all the zeros have a multiplicity of 1. On h of x, negative 4, negative 2, and 5 have a multiplicity of 1, and x equals 2 has a multiplicity of 2. So this is 1, 1, 1, but this one has a multiplicity of 2.
That's how many times it comes off of it.
Yes. So let me just ask you, what is happening where it has a multiplicity of 2 versus a multiplicity of 1? It bounces off. Okay. If it has a multiplicity of 2, it's not going to pass through the 0. Okay. It hits it and like ricochets. Okay. It's like boom. Passes through, passes through, passes through. Nope. What do you notice about how many zeros with their multiplicities and the degree? Like 1, 1, and 1 add up to be 3. You got 4 zeros with multiplicity of 1, and guess what? It's 4. But over here, there's 4, but how do you get that fifth one? Because it doubles, so it's a multiplicity of 2. 1, 2, 3, 4, 5. I feel like that's a song. All right, so we're not going to answer those questions, but look at this chart on page 503. All right, so it says for each of the functions in the chart below, graph the polynomial function on the calculator, paying close attention to how the function comes into the viewing screen and exit the viewing screen on the calculator. So here's what I want you to know, okay? Because we're not good. By the way, speaking of calculators, you have to start turning in your calculators on Monday. So
I never had one.
Monday, you have to start turning in your calculators. All right, so this is even with a positive lead coefficient. This is even with a negative lead coefficient. Even, negative. Even, positive. This one's odd. And it's positive. I'm looking at the lead coefficient and the highest number. Yep. So that one's odd, positive. 7 is odd, negative. Go ahead and finish that out. you have that much filled out? All right, awesome. Okay. I don't think we have enough time for me to graph these. We'll graph them Monday. So just hang on to them. We'll graph them Monday. On Tuesday, nobody will be here. Wednesday, we'll have some people out. We'll start talking about the test. Thursday, we'll talk in earnest about the test. And Friday, you'll take your semester test.
Anyone who plans to take a class at ANC this summer or fall for college credit and high school credit, I need you to bring